Point Pleasant Park's Ecological Comeback Post-Hurricane Juan, a presentation by Abby Muir, Cecilia Ricks, and Caleb Simmons. Point Pleasant Park is a significant urban forest located in present-day Halifax. This park holds cultural, ecological, and historical importance, serving as both a recreational space and a vital green space in the city. In September 2003, Hurricane Juan, a Category 2 storm, made landfall, with winds surpassing 150 kilometers per hour. It uprooted thousands of trees, causing widespread destruction and altering the park's ecosystem. The level of disturbance and damage caused made it one of the most severe natural events in the region's recent history. This disruption provides an opportunity to study ecological succession, which is the natural process of ecosystem recovery after a disturbance. Over the past 2 decades, data has been collected to monitor how the forest regenerates, including changes in species, compositions, and forest structure. Understanding succession in an urban park like Point Pleasant is particularly interesting because human intervention, such as park management decisions, the park's usage, and human-built structures, can shape natural recovery. Additionally, this research has broader implications for urban forestry, conservation, and climate resilience, especially as extreme weather events become more frequent. This research not only enhances our understanding of forest recovery, but also contributes to sustainable park management practices. We came up with 3 hypotheses. The first one is that the red spruce will be the dominant species once the population approaches climax community. The second one is that diversity will decrease as ecological community approaches climax. And the third one is that initially diversity will increase in the park, but over time, dominant species will outcompete the other and will lead to a decrease in diversity as the community reaches climax.
To interpret the changes induced by secondary selection at Point Pleasant Park, 6 study sites were used and were chosen based on the most significant damage incurred by Hurricane Juan. The areas of each site were 20 by 20 meter transects. To determine the changes made by succession, trees and shrubs were used as a study organism, among them being the red maple tree, which was the dominant species in 2023, and red spruce being the dominant species in 2004. The density of the species were counted per individual visually within the 20 by 20 transects, and were only counted if their diameter at breast height was greater than or equal to 2.5 centimeters. Growth data was gathered using diameter at breast height, which was measured 4.5 feet off the ground with a diameter tape measure, which was wrapped around the tree to get the diameter. This allowed for the growth documentation over each subsequent year. To determine the effects of succession on Point Pleasant Park, calculations using each of the 6 sites were individually calculated using Shannon diversity, where Pi is the number of individuals in a species over the number of species in a given site. This gives the diversity of that site. Evenness of the sites was also calculated, where S is the number of species in a given site. This gives us the evenness of the distribution of the species across a site. To assess the relationship between these variables over years, linear regression analysis was done to see if the changes imposed by selection by succession caused a significant change in the floral community of Point Pleasant Park. Regression analysis was used because this research is looking at changes over time and the relationship between each variable and time, and how that community may look in future years. These are the illustrations for the methods previously mentioned, where Figure 1 on the left shows the map of the 6 study sites chosen in Point Pleasant Park from the view of Google Earth, and Figure 2 on the right shows how the diameter of breast height was measured for every study organism, such that all measurements were taken at 4.5 feet when able to do so, and when this is not able to be done, the measurement is either taken above or below in some cases where the irregularity is located.
For the density of total forest community over time, we can look at the data from 2004 to 2022. We observe a fluctuating increase in the total plant density across the study sites. Initially, in the early post-disturbance years following Hurricane Juan, plant density was notably low, with very few individuals established. However, as time has passed, we see a clear increase in regeneration. The changes in the overall forest community over time, as seen in the figure provided, were measured from 2004 to 2024 and graphed as a linear regression. Although the total density fluctuates with an R-square value of 0.4926, there is a positive correlation between time and density. The relationship between density and time can be described as y equals 8.7215x minus 17489. The observed increase in plant density reflects the thriving of early successional species in the wake of Hurricane Juan's disturbance. This is due to natural succession and reduced competition. With fewer mature trees, newly established plants had improved access to light and nutrients. These species are particularly adapted to open disturbed conditions and have been able to take advantage of the light and space available in the years following the disturbance. As succession progresses, we can expect that slower growing, shade-tolerant species are becoming more established in the lower levels of the canopy. These species are typically less competitive in the early stages, but will play a critical role in the long-term development of the forest. Over time, the forest community is likely to shift towards a climax state, which is characterized by the dominance of mature species. This positive trend in the plant density and overall forest development highlights the steady recovery of the ecosystem after the disturbance. It demonstrates the resilience of the forest and its natural progression towards a more stable, mature ecosystem.
To assess the relationship between diversity and time in Point Pleasant Park, Halifax, Nova Scotia, regression analysis as seen in Figure 3 was used on the diversity over each of the 6 sites over 20 years from 2004 to 2024. The relationship was significant and positive between diversity among the 6 sites and time, with an R-squared value of 0.34, an F statistic of 38.8, and a p-value of 2.3 times 10 to the negative 8. This means that diversity in Point Pleasant Park can be predicted for future years by using the regression equation diversity equals 0.0606 times the year minus 120.85. Because Hurricane Juan damaged so much of the park and removed a lot of individuals from Point Pleasant Park, this left a colonizable opportunity for species that have high dispersal and reproductive rates, which also happen to be the species that were less abundant prior to Hurricane Juan due to shading. An example species would be red maple, which cannot survive in low light levels. Furthermore, the study Burleigh et al. Did in 2008 claims that the damage done by Juan was less ecological than it was physical, as the species which were there before are recolonizing the land, which is typical of early succession. To see the change in species richness over time in Point Pleasant Park, Halifax, Nova Scotia, according to Figure 4, regression analysis was done to assess the relationship between species richness across all 6 sites and time from 2004 to 2024. The relationship was significantly positive between richness and time, with an R-squared value of 0.61, an F statistic of 128.7, and a p-value of 2.2 times 10 to the negative 16. This indicates that species richness can be predicted for future years by using the equation species richness equals 0.5294 times the year minus 1059.4. While this relationship does indicate richness is increasing, succession can take many generations to reach a climax community, meaning because the community is in early stages of succession and competition has not yet set in, as stronger competitors become more abundant, species will begin to be excluded from the area. So as climax species become more abundant, they would inherently decrease the diversity at those 6 sites because of this exclusion principle. However, this exclusion will happen slowly because early successional shade-intolerant species like red maple had a head start and are shading shade-tolerant climax species like red spruce, slowing their recovery. However, it will only be slowed for so long because the generation time of climax species like red spruce are generally much longer than that of the early succession species like red maple, which means red spruce richness will increase as red maple trees die out, thereby decreasing diversity. Therefore, as the community moves towards climax, species diversity will increase but will eventually level off and decrease once red maple dies, because the next generation of red maple will not have that head start to avoid photosynthetic competition with red spruce. However, this process will be slow as red spruce recovery is being slowed by shading from early successional species.
The red maple species had a density of 0 in 2004, while the red spruce had a density of 7 individuals, both measured from the hurricane's most impactful area of Point Pleasant Park, in a 400-meter square area range. A year after Hurricane Juan in 2004, the red spruce was more resilient to the immediate damage brought on by the storm than the red maple, which was completely wiped out. However, in 2024, the dominant species changed. The red spruce, which was previously dominant, had a peak density of 17 individuals, while the red maple species had a peak density of 59 individuals, again in the same 400-meter square parameter. The red spruce was dethroned, and the red maple now serves as the dominant species. The red spruce is a late successional species that has a slow growth rate, in comparison to the red maple with a fast growing rate and displays early succession. Therefore, when the park reaches its community climax and is in a late successional environment, the red spruce will become the dominant species once again. The Acadian forest in Point Pleasant Park has not yet reached its community climax and remains in the early successional stage. This is shown as the red maple is dominant over the red spruce. The red maple has a fast growth rate and is taking advantage of the non-shaded region. If we were in the midst of reaching the late successional stage in maximum community climax, more trees would be grown in the area. We know this isn't the case due to the shade-intolerant species, the red maple, dominating the red spruce, due to there being less abundance of trees and more sunlight being able to shine through to let the red maple grow. Over time, when the park reaches its community climax, the red spruce will become the dominant species. By Point Pleasant Park being a public ground that is enjoyed by many citizens, there are many other influences impacting the success of its growth and recovery post-Hurricane Juan. The many people using the park, adding garbage to the ground, and stepping on its soil affects its ability to reach climax community, as effective nutrients used to help support the growth of these species are being disturbed. Another factor is that since the urban park is close to roads filled with cars, it is experiencing more rising temperatures to their environment. This would create a struggle for the native species in the park to survive under new conditions. This could also impact the way trees grow, as native species are a vital part of seed dispersal. Rising air temperature is an issue because it reduces the forest's ability to evaporate heat through transpiration, which cools the forest down. The warm air rising causes the land and the soil the trees need to grow to become dry and non-nutrition. This can all impact the amount of time it takes for various species to grow back. Two-eyed seeing refers to the practice of combining both Western and Indigenous knowledge to find the most beneficial approach. Using these perspectives together, we can maximize our resources for understanding and work towards the best outcome for the Acadian forest. We can apply our knowledge on climate change and use what we know about sustainability to help restore the Acadian forest. These ideas bounce off each other, as we know what causes climate change to occur and the effects it has on our environment, while combining our originally indigenous knowledge on how to sustain biodiversity, we can manage to support the forest and allow it to reach its healthiest state. For example, the indigenous way of sustaining the land is by protecting it and being mindful of the way we use it. It corresponds to climate change because it will prevent us from exploiting resources such as trees, which reduce global warming. Thank you, Dr. Alex Schmidt. You can roll